Hello students, in this third video under forecasting series, we will be understanding how the models are evaluated. We have seen, we have seen four different types of models. First, we have seen moving average type of model. Then we have seen weighted moving average. Then we have seen exponential smoothing, and then we have seen adjusted exponential smoothing. So once these models are deployed and we get the forecasts, we want to also know which one is more accurate, right? So because the organization has to finally decide one particular model which they should be using, depending on the model's accuracy, right? So here in this particular slide, we have this different types of accuracy measurements which can be used. So basically when we are saying accuracy, it's nothing but the forecast error which we are going to be calculating, and it is nothing but the difference between the forecasted value and the actual value, right? So if you look at this is our data, and we have the data from Jan to December, and basically we have done the forecasting here, and here we have used the exponential smoothing method alpha of 0.3, and we have got this particular forecast for February to December, right? Now to find out whether this alpha equal to 0.3 is a good model, we need to now calculate its the errors, or we need to calculate the accuracy. So we have four different measures here. The first one is called as mean absolute deviation, MAD. The second one is mean absolute percentage deviation, MAPD. The third is cumulative error, E. The fourth is average error or bias, which is E bar. And lastly, the mean square error, which is MSE, which is nothing but our famous variance. Okay, so basically these are the formulas which we are going to be using, but let us understand step by step. First, once we calculate the forecast, next step is to calculate the difference between the demand and the forecast. Now because we don't have a forecast here, as well as we don't have a demand here in the 13th Jan month, we'll be using only this particular pair of values which are available, where demand is also there and forecast is there. So basically we are going to use this 11 pairs, right? So for this we are going to calculate the difference between the demand and forecast in the first column, which is purely the difference. If the forecast is on a higher side, you will get negative value of this difference, and then the total of this is calculated here, which is 49.31, the total value. Then the next column we are going to calculate the absolute value of this difference, which is going to convert the negative values into positive values. And for this absolute values also we are going to find out the total. In the third column we are going to square the values, the difference of this column, and we are going to get the squared values and then the total of this squared difference, right? Now let us understand one by one the measure. First is the mean absolute deviation. So what exactly is mean absolute deviation? Is nothing but average of the absolute value, you see here absolute value of the difference, because we use absolute deviation. So basically here we are going to calculate the average of the second column total divided by 11, because we have 11 pairs. So that will give us our MAD, that is the mean absolute deviation. The mean absolute percentage deviation, here we are going to divide this value of this total right here, this total by the total of the total demand, right? So if you see here, basically we are going to use this 11 only, right? So with this 11 ka total we will find out and divide it, this 53.39 divided by 520 is going to, and multiplied by 100, you will get the mean absolute percentage deviation, right? Now what is cumulative error? Cumulative error is without the absolute values, that means the actual difference along with the negative values. We are just simply going to find out what is the total error in this pairs. So 49.31 is the total value here, the total of this, which is nothing but our cumulative error. And when you divide this cumulative error by 11 or the number of pairs, you are going to get this 49.31 divided by 11. So because there is no absolute value mentioned here, absolute, this is cumulative and this average is from the first column. These two where absolute is written, these two are from the second column, right? Now the third column is nothing but the squared, and hence the squared error, mean squared error is here. We are going to use this mean squared error here, right? And this is your MSE, which is nothing but your the variance. So how we are going to do this? We are basically going to calculate the total, and this total divided by 11 is going to give me the MSE, mean squared error, right? Now this is for this particular forecast which we have used alpha equal to 0.3. Suppose you have another method of forecast or another alpha or alpha and beta. First you are going to calculate the entire this table of forecast and then create these columns to find out the errors or values for this particular forecast. Suppose the other alpha equal to 0.4, right, gives you different MSE. Maybe it is the MSE is lower than this, that means alpha equal to 0.3 model is more accurate. Lower the error, more is the accuracy of that particular model. So maybe in the exam you will be given two different models and you will find out the forecast from two different models. Find out the given parameter, right? Mostly they will give you MSE, sometimes they will give you all, right? So find out the MSE for both the models, and whichever model has lower MSE is the model which we should recommend the organization to be using, because that is more accurate, right? So that's how we use this particular forecast accuracy to find out which of the given models is more suitable for forecast. Thank you.